My name is Elijah Cruz, and this video will be on the properties of limits. The properties of limits are the multiple theorems that help us calculate many unfamiliar limits from ones we already know. With the following rules, we can calculate the limits of all polynomial and rational functions. So, these are the 6 rules of limits. Let's say that the limit as x approaches c of the function f of x is equal to L, and the limit as x approaches c of the function g of x is equal to m. Let's remember this. Now the first rule that we are going to do is the sum rule. The sum rule is the limit of the sum of two functions, which is the sum of their limits. So the sum rule looks like this. The limit as x approaches c of the function f of x plus the function of g of x. Now this is equivalent to saying the limit as x approaches c of the function f of x plus the limit as x approaches c of the function g of x. Now, earlier we found out that the limit as x approaches c of the function f of x is equal to L, and the limit as x approaches c of the function g of x is equal to m. So the limit as x approaches c of the function f of x plus the function of g of x is equivalent to saying L plus m. Now let's do an example. Let's say the limit as x approaches 2 of x squared plus 9 plus x. First, we'll need to simplify this. So the limit as x approaches 2 of x squared plus the limit as x approaches 2 of 9 plus the limit as x approaches 2 of x. So now we substitute x for 2, and we leave 9 the same because the limit of a constant is that constant. So it'll be 2 squared, which is 4, plus 9, plus 2, which is equal to 15. So the limit as x approaches 2 of x squared plus 9 plus x is equal to 15. The next rule that we will do is difference rule. Difference rule is very similar to sum rule. The only difference is we are doing subtraction instead of addition. So instead of L plus m, the equation will be L minus m. The third rule we will go over is the product rule. The product rule is the limit of a product of two functions, which is the product of those two functions' limits. The product rule has the same concept as the sum rule and difference rule, but we are using multiplication. So instead of doing L plus m or L minus m, we are using L times m. Let's use an example. Let's say the limit as x approaches 0 of tangent x over x. Now let's simplify this. So we can say the limit as x approaches 0 times sine x over x times 1 over cosine x. Now let's simplify this even further and distribute it. So the limit as x approaches 0 of sine x over x times the limit as x approaches 0 of 1 over cosine x. So we know that when x is equal to 0, that sine x over x is equal to 1. And we know that cosine 0 is equal to 1. So it'll be 1 times 1 over 1. And this is equal to 1. So the limit as x approaches 0 of tangent x over x is equal to 1. What we will go over is the constant multiple rule. The constant multiple rule states that the limit of a constant times a function is the constant times the limit of the function. For this rule, instead of using the rules of operation on two functions, we are using it on a constant and a function. So instead of L times m, we have k times L. Let's do an example. Let's say that the limit as x approaches 2 of 3x squared. Now we can simplify this using the constant multiple rule. So first we will move 3 to the front of the limit, so it'll be 3, the constant, times the limit x approaches 2 of x squared. Now we can substitute x for 2, and we will have 2 squared, which is 4. So this is equal to 3 times 4, which is equal to 12. So that means that the limit as x approaches 2 of 3x squared is equal to 12. Fifth rule we will go over is the quotient rule. The quotient rule is when the limit of a quotient of two functions is the quotient of their limits, provided the limit of the denominator is not 0. So that means that the quotient rule is similar to the difference rule, the sum rule, and the product rule, but instead of using subtraction, multiplication, or addition, we're using division. So instead of L plus M, L minus M, or L times M, we are using L divided by M. But in this case, M cannot be equal to 0. Now let's do an example. Let's say that the limit as x approaches 1 of 3x over x plus 5. Now let's simplify this. So the limit as x approaches 1 of 3x over x plus 5 is equal to, using constant multiple rule, we can move 3 to the front, and we'll have 3 times the limit as x approaches 1 of x over the limit as x approaches 1 of x plus 5. So now we will substitute 1 for x, and we will now have 3 times 1 over 1 plus 5, which is equal to 3 over 6, or 1 over 2. So the limit as x approaches 1 of 3x over x plus 5 is equal to 1 over 2. The last rule that we will be going over is the power rule. The power rule for limits states that the limit of the nth power of a function equals the nth power of the limit of the function. So that would look like this. The limit as x approaches c of the function f of x to the nth power. And this is equivalent to the limit as x approaches c to the function f of x to the nth power. And we know that the limit of x approaching c of the function f of x is equal to L. So this would just be L to the nth power. Now let's do an example. Let's say that we have the limit as x approaches 5 of x plus 1 to a square. Now, the limit as x approaches 5 of x plus 1 squared is equal to the limit as x approaches 5 of x plus the limit as x approaches 5 of 1. So we can keep 1 the same because the limit of a constant is that constant. So it'd be 1. But we can substitute x for 5. So it'll be 5 plus 1, which is equal to 6. And now it'll be 6 squared, which is equal to 36. So the limit as x approaches 5 of x plus 1 squared is equal to 36. The changes in the economy of Guam, specifically inflation, have been monitored to follow the function f of x is equal to 3x squared minus 4x plus 5. With this trend, at what percent will the inflation be after 2 years? Now we can write the limit as x approaches 2 of 3x squared minus 4x plus 5. Now we can simplify this by using sum difference rule. So this would be equal to the limit as 3x squared as x approaches 2 minus the limit as x approaches 2 of 4x plus the limit as x approaches 2 of 5. Now we can simplify this further by using the constant multiple rule. So the limit as x approaches 2 of 3x squared minus 4x plus 5 is equal to 3 times the limit of x squared as x approaches 2 minus 4 times the limit as x approaches 2 of x plus the limit as x approaches 2 of 5. Now we can substitute 2 for the x's. So this will now be equal to 3 times 4 minus 4 times 2 plus 5, which would be equal to 12 minus 8 plus 5, which is equal to 9. And since it's asking at what percent will the inflation be after 2 years, it'll be 9%. So the limit as x approaches 2 of 3x squared minus 4x plus 5 is equal to 9. And we also have proof of 9% being correct in this graph because as x is equal to 2, our f of x is equal to 9.